anyway, even if we're not gonna use it. I'm also expecting around 10 participants, so probably 2 people are missing. How many weeks we're on? I believe we are on week 4. This is us. So let me remove all that and start fresh with you. All right, so what does it say? It says that we have lab 1, you should receive the corrections today. Actually, everybody in this section already received the corrections, right? If you did not for a reason, let me know. If you don't agree with some of my comments, also let me know. If you don't understand a section, also let me know. Concerning lab 2, let's take some time to answer your questions. Giscard, you did not receive it. Let me see. So if I go to assignments, let me check your name. Probably I got disconnected for a reason. So Giscard, by the way, that's not your class, isn't it? But it is your class. Giscard, you have 95% and definitely you can read the comments. Okay, so try to go into the lab, which is here, and try to go into the comments. By the way, I'm writing comments. The comments are here. Okay, I'm writing comments because I don't want to comment directly on your lab report. I used to comment directly on the lab report, but I decided not to because some students are working in pairs. So probably if I write some comments, I can copy paste for both partners. You want to check the comments? I don't know, try to click on the grades. I don't know from your side. Mia, you want to share your screen so I can show you how? Or you try and tell me, yes, please share your screen. Let me stop sharing myself. It shows next to the grade. Clara is saying this. So if you go to, do you have anything called grade center? Where do you go for the grade? Try to go into the course. You get a notification. Okay, yes, if you click on it, what happens? You see feedback. Oh, this is so much better. Probably if I write directly on the lab report, you would be able to see it. I don't know. All right, if it's working for you, that's great. Okay, thank you. Yeah, it's important for us to communicate. Now, if you want to stop sharing, so I can share if you, yeah. All right, same with the others. So yeah, let me go back to the users. Yeah, and so now, according to our plan, we need to discuss any question you have out of lab 2. Go ahead, if you want to write on the chat, you can. If you want to speak up, you also can. Any questions related to lab number 2? Zilla and remind me who as well. If you want to speak up, you can. Otherwise, you wait for me to answer through email. Do we take a theoretical to be, so a theoretical is actually equal to g sine theta. And you can take g to be equal to 9.8 plus or minus 0.1 meter per second squared. All right? Yes. How do we calculate it by a... All right, so it's easy to calculate the acceleration, but probably not easy to calculate the error on A. How do you calculate the error on A? You need to do the derivatives. I would like you to try, okay? Be careful. Don't forget to convert the uncertainty on theta, all right, to radians. Don't keep it in degrees, okay? I need to switch this button, wait. Okay, I'm back. So, yes. Any other question? Probably you still need time to go through the lab report and ask me in the afternoon or later on. And I'm also sorry if I'm a bit slow answering your questions. Just keep in mind that all the students are asking all the questions on Monday and Tuesday only. So it's not like people are asking questions over the week. It's all coming in one shot. So I'm trying to cater for the needs of everybody, but sometimes it doesn't work, but it's okay. So far, so good. No questions for lab 2? That's it? May I ask you please to open your cameras for at least the first 10 minutes so I can see you if possible, because I have a feeling I'm talking to my screen. All right, no questions? Yeah.
I have a question for lab 2.
Okay.
In question 5, you should acceleration in terms of mass and thought. Here is the specific form how it should be according to drawing.
Okay. Gael, put your camera away. You're glitching. I'm sorry. Yes. I'm going to open the manual for you while you explain again what the question is. Yes, Gael.
Okay. My question was in question 5, we were asked to find the acceleration in terms of theta and mass, and after we draw the sketch.
Yes.
Yes, there is.
So in question number 5, they want you to devise a procedure, right?
Yes.
Okay, so try to come up with a thought experiment. List the material you need, sketch the setup, and explain how the acceleration is mass dependent.
Okay.
Did I answer your question? Because I couldn't hear your question.
Here, what we were asked to find derive the equation of the acceleration, yeah.
Yes, yes.
There is specific form.
No, you do net force equals ma. You show all the forces. You do the x component, for example, and the y component, and you find the acceleration as easy as that. Okay. Of course, Mia, you can do the inclined plane model, but be careful, Mia. If you take the inclined plane and the only force is the force of gravity, you will end up with mg sin theta, and m is going to cancel out. So make sure you have something along the mg sine theta. Two masses, an extra tension, extra friction, anything would help. Okay. All right. Any other question related to lab 2? I suppose things are okay, and of course you can still ask later on. Now, according to our plan, we need to do linear regression and we cannot postpone it anymore. I'm gonna try to be efficient, not quick, efficient, and probably not talk about things we don't really need to cover. But anyway, we have a data analysis part 2 that we were supposed to cover during week 1 and we did not, all right? I'm gonna share it with you and I'm gonna go over it quickly and take my time over the important stuff. Okay, the content was, because this was supposed to be done during week 1 and 2, but we decided to start the labs directly. How is a graph a communication tool? Why linear relationships are important? How do we calculate the slope? And this is very important. Just a second. Why is this doing that? Anyway, so I wanted to highlight it. This is very important because in lab number 3, you would need to calculate the slope and the error on the slope, and you need to use the slope. So what is the slope needed for? So how do I use it? And how do I calculate the error on the slope? And definitely you have many methods to follow. Discussing a graph as a good communication tool. Here I'm trying to tell you something that you guys are very good at by now, that it's very important to show a title, very important to label the axis, to add units, to show a very clear legend. And you already know a bit how to do that because your lab reports were good. You can see here, I'm sorry, you can see here some graphs that are good or bad. Sometimes you see a unit, like here, the axes are not very well labeled, probably the legend not super clear. I don't see a title. Here you have brand BCDE, so the x-axis you don't see a unit. The legend is clear though, a title is missing. In here, both axes are not labeled and the title makes no sense, does not give me extra information. Here, probably I can take this to be the title. The y-axis is not labeled. The x-axis is the date, so it's okay. The legend is not clear. So yes, now why linear relationships? Every time you do a certain measurement, you will end up with scattered value. Those values would represent a linear relationship or not. You see the curve here? So you should know how to assess your values, linear or not, and you should know how to find the red line, and the red line is the best fit. Okay? The best fit is basically an average. And it's something that goes through the points, like in between. Sometimes the average will not pass through any point. It's like really in between. Here I'm showing you some examples. This is an example of a simple pendulum. Let's see if this is, let me use a thicker pen. I don't know if you remember from high school, the period of a simple pendulum, it was 2 pi radical L over G. Probably you did not do pendulum in high school. Probably you did the spring mass system where the period is radical M over K, which is very similar. So if you plot T versus L, and probably I can ask, let me have your list of names here so I can interact easier with you. Probably I can ask Giscard. Yes, so Giscard, if you plot, Giscard, are you there? If you plot T as a function of L, do you get a straight line passing to the origin? Are they proportional, T and L? Looking at the equation. Yes?
As L increases, T increases, but they're not, like, the line won't pass through the origin.
Why not through the origin? L is equal to 0, T will be equal to the 0. So I know for a fact that it's going to start from here. But the question is, would it be linear or a curve? Or probably this, or probably this?
A curve.
How do you know?
Because it's under a radical.
Exactly. So it's not a linear relationship. And please don't say in this case that T and L are proportional. You can say T and radical L are proportional. You can also say L and squared, T squared is proportional. All right. So this will give you something like that, and you can see it here. The reason why it does not pass through O, probably it's due to a very tiny source of error. But if you ever do T squared versus L, and we can write the equation of T squared. Giscard, can you help me? T squared would be equal to, obviously, L over G, because the radical is going to go. And 2 pi will be
squared.
4 pi squared. So now, do you believe T squared and L are proportional?
Yes.
Yes, they are. And therefore, you get a straight line passing through the origin. And you can see the equation of the straight line. It's T squared. Can you tell me, Giscard, what's the slope in this case? If you look at the equation.
4.0417.
Yes, and can you tell me what is the unit of the slope?
Second squared per centimeter.
Exactly. So the unit is the unit of y over the unit of x. That's the slope. So second squared over centimeter. This is awesome, brilliant. All right. So, and there's an r squared function here. This r squared function, I'm going to talk about it a bit more in a while. This tells me how straight my line is, how linear my points are showing. So r squared should be equal to 1 if I have a perfect line. 0.99 is great, you know. Like in this case, I expect to get something like 0.98, 97, or 0.9, or probably 0.8. I don't know. Probably this is a sine function. So for me to be able to say it's a super straight line, I need to look for the r squared function. All right. This is another example of total mass versus the number of craters. And you see the equation of the line. For example, Naya, what is the slope here? Yes, Naya.
It's not a permitting. I don't think she's in the meeting.
Okay, so probably you can answer, Gael.
Okay, but what was the question again?
The question is, in this case, what is the slope?
The slope
The value of the slope. It is 2.5. Can you tell me the unit for the slope?
Grams per number of crackers.
Exactly. By the way, it's written here. I just saw it. Yes. All right. Do we have the R squared function? No, it's not given. Here, I want you to look at the different values. You have the slope for all the values. By the way, they're plotting ln E versus volume, right? Ln E probably because E is an exponential, and by doing ln E is to force the function to become linear. You see different R squared functions, 0.98, 0.86, because probably the points are very highly scattered. And here we have 0.96 and so on, okay? Yes, I just saw Clara's comment. Here, Clara, do you think this is a linear function if you look at all the points?
No, it's making a curve.
Obviously, I cannot assume this to be linear. And the R squared function is very close to 0.1. If you do this squared, you will get something very close to 0.1, which is so much far than 0.9 or 1 itself. So this shows you that your actual plot is not a linear relationship. So I'm going to save this under your name just to send it to you. All right, now how do we calculate the slope? You usually do y2 minus y1 over x2 minus x1 or rise over run. Please do not do this anymore because you can only do this if you have 2 points on the line. And so far you don't have a line. You will be given points like the blue points and the red line is not there. You're supposed to find the equation first, the slope first, then draw the line, which means you cannot pick 2 points on the line because the line does not exist yet, you see? So please do not use this method. You have 2 methods to find the slope. Either use Excel, and I'm gonna show you how, or use the calculator. I'm gonna send you a video as well. However, I believe no need to waste our time on the calculator since we do have Excel and all the exams are gonna be computer based if you will be on campus or not, you see? Excel is nice to use. However, using the calculator is quick as well. So if you wanna learn both, go ahead. I will send you a video done by me on my own calculator so you can have a look. You just put your X and Y, click linear regression, give me the slope. That's it. Now for the Excel, I'm gonna open Excel for us. Meanwhile, I'm gonna show you the slide. It says that you put your values X and Y, you select, you click add scatter, and that's it. Let me show you how. So I'm gonna label X and Y because I don't wanna be confused. I'm gonna give randomly some values. I will make it perfectly linear and then I will change it for us. I will increase the font so you can see and center it. Okay, now what do? I will select the values only. I put X first, then Y, then insert, scatter. I will pick the one without a line because I want to do the line manual. Don't forget to change the title and to add some elements like axis and units and so on, legend. All right, then what do? I right click on the points, right click, add trend line. And when you add the trend line, make sure it's linear, not exponential, not polynomial, so linear, and add equation and the R squared value, all right? And now you have it. I don't know if you can see it, but يعني حرام هول العالم اللي عم يشتغلوا بكونوا انطوشوا. All right, so yeah, you see? The slope is in this case, Madzilla, what's the slope here?
10.
10. The unit is unknown because we don't know the unit of y and x. And you see the R squared function is equal to 1 because I gave a superlinear value. How about I change those to 15, 32, 41, and 70. All right, let me change this to 55. You see the points are changing a bit. 2.8, how come the slope is not? 5.2. All right, the slope should change. If not, I'm gonna delete this, and double click and add an equation again with the r squared. You see, it's a bit different now. All right, probably it doesn't change. Make sure you remove the equation and put a new equation. You see, the slope changed a bit and the r squared function is not perfectly linear anymore, okay? So this is the easiest way to find the slope of the best fit line. And again, the best fit line is not there. It's an average line that would go through the points in between, okay? I will show you probably how to do that on a video, or just you can watch the recording to be able to remember. Okay, all right. Now this was supposed to be an assignment, but it's not anymore. The question is, use Excel and the calculator to find the resistance. So you can easily plot U versus I. This is Ohm's law, and the slope will actually be the resistance. And the slope is gonna be R. So you can easily do it on Excel. Now, what does the slope represent? What did I hide here? I can't remember. Probably I can try to remove it. Okay, undo. Let's do our own. Probably I can ask Yara. Yara بعد عم تسرق شوكولا. وينا Yara? She's not with us. هلا شوي بتجي يارا. All right, so George. Yes, George. So if I plot F versus A, do you get a linear relationship? I'm focusing on Newton's second law. Do you get a linear relationship? Is that also a yes?
I think so. I mean, it depends.
All right, it depends if M is a constant. This is what you mean.
Yeah.
All right, assuming M is a constant, do you believe I get a linear relationship?
Yeah, they would be.
Okay, and what does the slope represent? So this, what is the slope? So y versus x, this is y, this is x. The slope is M, right?
Yeah.
All right, now I'm gonna plot something else. I'm gonna plot A versus F. M being a constant. Do you believe you get a linear relationship?
Yes, they're also proportional.
Okay, and what does the slope represent?
M as well.
It's 1 over M, actually.
Or 1 over M.
Yes. Now, if I ever plot, let's say the force is constant and I plot A versus M, do I get a linear relationship?
No, they're inversely proportional.
So you get a hyperbola otherwise. Yes, awesome. Thank you so much, Giuseppina. Let's discuss this function. All right, we already did actually. This is very similar to F equals ma. Let me just ask you something. What is the slope if I plot t squared versus L? I will get a linear relationship because we already discussed it in this example. T squared versus L, it was linear. The question is, what does the slope represent? Is it pi? Is it 2? Is it g? So t squared is equal
2 pi over g.
You're very close. Let's write the equation L over g, right? So I'm writing t squared. Then I'm gonna take this to be my y and this to be my x, all right? So this would be my slope. So what would be the slope?
4 pi squared.
Exactly like what Mia wrote.
4 pi squared over g.
Yes, excellent. All right, so you should know what to plot. You should know if it's linear or not. And you should know what the slope represents. And this is coming in lab 3. That's why I'm doing it. Now, how do we find the error on the slope? You see, those points are on the line, or they give you a best fit line on them. But if you have some scattering, all this scattering, I need to find the deviation of the points away from the line to find the error. And by deviation, you see here, you have a lot of deviation or scattering around the average, which is the red line. All right, so here in this case, I want to measure the vertical deviation. Do you see the vertical deviation? It's this line. How far away is black point from the blue line vertically? Not this line, it has to be the vertical deviation. So I'm gonna find the deviation for every single, where am I? Here. Okay, I wanna find the deviation for every single point and do it squared, and then add all the deviation squared exactly like in the RMS, which is the standard deviation divided by radical n. And then I'm gonna do some calculations to find the error on the slope. How do I find the vertical deviation? I'm gonna do y of the point minus y of the line. Y of the line is actually ax plus b, or if you want to call it bx plus a, because some people call the slope b and the y-intercept a, depending on if you're using a Japanese calculator or an American calculator, and it doesn't matter. So this is this y, and this y is basically the y ordinate of the y coordinate of the point, because every point has an x and y coordinate, right? So you do the difference, easy. All right, how do we do the error on the slope? I would want you to watch the video done by me on paper to show you how I use this equation with an example. But anyway, I want to go over it again. What is EI? Like E1 is the difference between y of 0.1 and the equation of the line. Okay? E2 is y2 minus the equation of the line at 0.2. And then you square each, and then you add them all up. And you can do it on a calculator or on an Excel spreadsheet. How I do it on an Excel spreadsheet, for example, if I want to do y squared, I simply write y squared, for me not to forget, and do equal this squared. And I can simply drag throughout all my points. So please don't carry each calculation on a calculator. Use an Excel spreadsheet, do one calculation and scroll down, like drag down all the values. And then if you want to do sum, you can do this, click sum, which is here behind my face, sum, you just got the sum. If you want to do the sum of this guy, you do the sum of this guy, and then you want the value of this one squared, you do this one squared, you're done. So please don't use your calculators if you can do it on Excel. All right, now let me continue. N is the number of points, so n minus 2 is the number of points minus 2, and then sigma xi squared is x1 squared plus x2 squared plus x3 squared, and this is the sum of x, final answer is squared. And definitely here, Excel sheet again, you have all the x's, you can square each and then find the sum, or you can find the sum of x and square it. So sounds like time consuming, but on an Excel spreadsheet, you scroll down and you finish it in 5 minutes, maybe less. Okay, by the way, delta is here, this one. Don't forget, this is the error on the slope squared. So you need to make radical for the whole equation, final answer. And don't forget to follow the 3-point system. Make sure to round to 1 sig fig, make sure to add a unit, and make sure to round the slope according to the error. So if the error is 2 decimals, round the slope accordingly, okay? I know this is a lot, so probably we're gonna practice this week and next week before the midterm, okay? And this is another example, calculate the error on the slope. Please don't do this as an assignment. You already have lab number 3 to try. All right, talking of midterm, I have a tentative date. And tentative date means not a final answer, but I would want to give you the tentative date and take feedback from you. Probably Saturday, March 20. I already told this to my Monday section. Actually, they asked for it to be on March 20 on a Saturday for many reasons. I need to remind you that we are 6 sections, and no, we're not gonna do this with Beirut. So us, only Biblos, 6 sections. That's why it's a Saturday, just to cater for the need of everybody. I don't know the timing, but I have a regular class in Biblos at 11. So it's gonna be around noon or in the afternoon.
Can't we do it like at 10?
before my class. إذا عبالكم ليش لا at 10 a.m. I don't know. I listen to you. All right. I think it's gonna be awesome.
إيه دكتور أحسن إذا الصبح لأنه on the Monday after the exam عندنا chemistry فتنلحق نراجع chemistry كمان.
When is the exam of chemistry? Listen, when is chemistry?
هو March 20. The chemistry exam is 22.
Okay, 22 is a Monday, right?
Yes, إنه تكون عندنا وقت ندرس له فإذا in the morning أحسن.
هيك بتخلصوا من الفيزيكس you will have all of Saturday to study, otherwise بيطير Saturday.
Yes.
Okay, you have a point. All right, let me see with the other sections. بركي حدا عنده صف. بركي the instructor of the other sections cannot make it. Personally, I don't see why not. All right, طيب. We're gonna talk. We have some plenty of time. We can talk about this later. Now I'm ready to start lab 3, and I think our presentation is ready. Where is it? This. Lab 3 is not tough. I'm only worried about the part where we need to do the slope and the linear regression, that's all. Okay, how's the midterm like, George? I don't know yet. Let's specify the date so we can focus on it. Probably it's gonna be 1 hour, 40 minutes, probably multiple choice section plus a subjective section. If it's multiple choice, I can give you some values, you find the average, or I give you ABCD, you pick which one is the average, which one is the RMS. You will have some conceptual questions. I mean by conceptual, not calculation, like how the range varies with the velocity and you pick from ABC. Probably if we're gonna give you a subjective part, we're gonna give you some values and ask you some questions. Okay, probably plot, find the linear regression and so on. I don't know, George, but yes, I will let you know soon. Okay, the outline. We need to discuss acceleration in general. What's centripetal and tangential acceleration? Newton's second law to find the centripetal force, the experimental setup, and analyzing your data. All right. In other words, what are the questions and how do we do the work? How do you define acceleration? You tell me. Yes. I'm all ears. You can speak up, you can type in the chat.
Squared over R.
Say it again.
V squared over R over the radius.
V squared over R. All right. That's the centripetal acceleration you mean. My question was, how do you define acceleration in general? Change in velocity, Clara, is not very precise because change in velocity is meter per second and acceleration is meter per second squared. So there's something missing in your statement, Clara. Anyone else? Acceleration in general. What is acceleration? It's an English word. You can find it in the dictionary. Ability to gain a velocity, close, throughout a period of time, adding to Clara. Yes, so change in velocity over time, change of velocity over time. This is the answer of Clara and Mia combined. Jessie would say it is the rate at which velocity changes, and which is exactly the same statement as Clara and Mia, but written in a very specific way. By the way, rate means per time, okay? Ability to gain velocity, George, I cannot say it's wrong, but ability, the term ability is blurred. And gain velocity, I agree, and I don't see a time component yet. Anyway, now, and I have another question. How do you define velocity? Because we need to discuss the change in velocity. Now we need to discuss velocity. So velocity is anyone? Rate at which the displacement is changing, Mia. Yes, bravo, Clara. Yeah, we can say that. Can we say velocity is equivalent to speed? Do you agree velocity is equivalent to speed? Not always, no. So is it speed with some modification? velocity and speed, how are they related? Speed, distance instead of displacement. All right, so you're saying, so what's the difference between distance and displacement? Velocity depends on direction. Thank you so much. Giscard is saying velocity is a vector. So I'm gonna call it a vector. How come I cannot write? So vector, which is speed plus direction. And this is very important, okay? So every time the velocity is changing, it means that the speed is changing and or the direction is changing. I was typing here. That's why I did not type on the, yeah. So now if the speed is changing, probably I can insert a text box to show speed and another text box to show direction, because I don't want to write with my trackpad. It is slow. Direction. All right. By a change in speed, I'm going to call this the tangential acceleration and call it A tangential. Tangential means tangent to my motion in the same direction or opposite, depending if I'm speeding up or slowing down. And change in direction, I'm gonna call it centripetal acceleration. Some people call it normal acceleration. Normal means perpendicular to my motion, okay? Because the job of the centripetal acceleration is only to change my direction. So this is equal, and this color is not great. Let me make this a bit thick. All right, this is basically equal to V final minus V initial over time. And here I'm only discussing magnitude of V as in speed. And A centripetal is exactly what your friend said. She said it's V squared over R. So it is proportional to V squared, not V, which means the faster you are, the more centripetal acceleration you feel if you want to turn. And for the radius, the smaller the radius, the more centripetal force you feel if you want to turn, okay? So now you know that, and I know that you know this from high school, so this is a review for you, that you have centripetal acceleration and tangential acceleration. Now to discuss the centripetal force, I'm gonna start by doing net force equals MA. So purple, I think, is the best on blue. So I'm gonna say net force is equal to MA. I'm going to assume that all the forces I have, so this is a vector equation. I'm going to assume that all the vectors forces I have are centripetal. So I'm going to call this to be the net force along the center to be equal to MA centripetal. Again, let me stress on the fact that A centripetal is not one force, one specific force. It could be many forces together. It is a resultant of some forces. It could be a tension in the wire. It could be the mg and the normal together to give you mg cos to cancel the normal, and then mg sin as the centripetal force. And I'm going to show you some examples in a moment. So the centripetal force is not a specific force. It is any force. It could be any force, and it could be the resultant of any two forces, as long as it is directed to the center of the motion, and as long as its only job is to make my velocity change direction without speeding up or slowing down, it's gonna be centripetal. All right, by replacing the acceleration by V squared over R, I would get the centripetal force to be equal to mv squared over R. All right, these are examples. This is a satellite. The only force on the satellite is the gravitational force. And you see that the gravitational force is centripetal because it's always directed to the center, right? So here you have the centripetal force example, and I should save as, it's okay. I can delete whatever, okay? And here in this case, you have a girl spinning a ball on a string. The centripetal force is the tension in the wire. Here the centripetal force is mg and the normal, so the resultant of both. Here for the car, do I have another picture of the car? No. Here for the car, the centripetal force could be friction, Or it could be the normal along with the mg. If the road is not horizontal, the road could be tilted at a certain angle. So you have mg and the normal. The resultant could be towards the center of the motion. All right? Anyway, don't worry about this. I want us to worry about our own setup. Our own setup is not very easy to understand. But once you understand the setup, the physics is straightforward. This is our setup. This is a picture, a diagram I mean, and this is a real picture. All right, let's see what we have in the picture. Please stop me if I'm going fast. I'm just bothered by the noise. This is a simple stand. And this is a rod. On the rod, I have a ruler that can rotate. The rotation is very smooth, you're gonna see in the video. Those are not in my experiment. Those are extra masses. Just forget about them. What we have is an empty ruler. By the way, on which you have graduations like a regular ruler. This is called a central post. Why do I need it? Central means it's at the center of the ruler. You have a spring. So this is basically a spring attached to an orange indicator because I want to keep an eye on the orange level. And here you have a ring that is transparent. The orange indicator can go below the ring or above the ring. It helps me locate something. And then this is attached by a wire around the pulley. This is my system. I'm gonna call it system. In the lab report, they don't call it system. I'm gonna change the name in the results because the students, your friends of section Monday, they were confused between the mass of the system and the mass of the hanging mass. And they got weird results because of that. This is my system, the mass of which is 200 grams. Don't forget to convert to kilograms when needed. It will be given in your results anyway. The system is attached by 3 wires. One wire here, one wire here, and one wire here. And here you have a hanging mass. I'm gonna call this small m and this big M. Okay? I will fix my setup in such a way to have this wire vertical straight, not tilted like that. By the way, if you add a mass in here, you will have, I don't want to call it equilibrium, but all the wires to be aligned. If this wire is not aligned, where's my pen? If this wire is not horizontal, you can fix the pulley up and down to make it horizontal. For this one, you can have a smaller, shorter wire, longer wire to help you align this one to be vertical, okay? If this is longer, probably this will be more horizontal. So you can fix the alignment and you will take your time. By the way, I'm gonna do the fixing because I'm gonna do the experiment. I'm gonna show you in the video, I think. All right, so this is another diagram with annotations. It says this is the rotating platform. This is the central post. This is the slide post because I'm gonna slide it right and left to vary the radius of my system. By the way, the radius of my system is measured from the center to its actual position. You see the hanging mass? All right, now I'm gonna ask someone, and this someone is this someone could be, I don't know, Giuseppina probably. So Giuseppina, the question for you is, what happens if I remove the hanging mass? And if Giuseppina cannot answer, probably Rita can try. What happens if I remove the hanging mass? You can say, I don't know. We can ask Gael, we can ask George, Zilla, Clara, anyone. What happens if I remove the hanging mass? If nobody answers, I would think I'm disconnected. Okay, it is lagging. Can you repeat? So my question is, what happens if I remove the hanging mass? So again, my job was to create a perfect alignment. This wire is pulling the mass in this direction. This wire is pulling in this direction because you have a spring, remember, and the spring is stretched. And this wire is doing nothing, only making the system to be hanging. Now the question is, what happens if I simply remove the mass? There will no longer be perfect alignment, perfect Mia. So in other words, the mass, this system, will move a bit in this direction. So I will have something like that. Now, my other question is, I'm gonna remove the hanging mass and remove the pulley. And let's see if I can move this to the side. I'm gonna ask my system to start rotating. Okay? What happens to my system if the platform is rotating? Do you think my system is gonna stay still or move to the center or away from the center? It's gonna move away because of some centripetal force. If the system is back to its original position, can you tell what is the centripetal force? Back to its initial position. Remember, the initial position is due to the weight of the hanging mass. Can I say the centripetal force is equivalent in magnitude to the weight of the hanging mass? This is very important to understand. I'm done with the experiment. And believe me, students are not being able to understand this. Let me repeat. I'm gonna put a hanging mass, which will create a hanging weight. I'm gonna create alignment. Then I'm gonna remove the pulley and the hanging mass. The alignment will be broken. I'm gonna start rotating my platform, slow or fast, until I get the system to be back to its original position. If the system is back to the original position, I'm gonna say the centripetal force is very similar to the old hanging weight because it gave me the same result. Okay? All right, now my question is, how can I know that the system is back to its original position? I'm gonna use the red indicator and the ring. I can move the ring up and down to put it on the red indicator. I'm gonna show you in the video. So this will remind me where the red indicator was. So when the system is disrupted from its original position, the red indicator will move up. When the original position is back to normal, the red indicator will go back to the ring. So this would help me know if I should turn the platform faster or slower. That's all. Right? By the way, you're gonna move the platform with your hand. That's great because you can touch the platform and make it slow or fast. Now, before going to analyzing my values, I want to show you the experiment for you to make sense. By the way, I deleted the video by mistake and I cannot find it in the trash. It's on YouTube, I know. These are the two parts of the video. I don't know if I cropped anything out of it. Hopefully not. So let me show you on fast forward. The video is not super great, but it's okay. Here I'm talking to you, saying nonsense. This is the platform, it's really fast. I'm explaining here the central post, the spring, the orange indicator, okay? I'm showing you the wire, it's not connected yet. I think I stopped the video only to create wires, make them shorter or longer. You see the pulley, I'm explaining the alignment, and I think I'm gonna show you the thing to be well aligned. Okay, not yet. Now let me show you the second video. Okay, the second video, I'm actually, oh, you see it's not aligned yet, but I took a break to create a node to be able to attach the system. By the way, this is my system. Orange indicator, and the ring here is black, but it's see-through, like you can see the red indicator whenever it goes through it. Okay, here I moved the black indicator up. Let me show you again. It was down, I moved it up to be exactly on the orange indicator, to remember where the orange indicator was. Because whenever the system would move right and left, the orange indicator will go up and down. I need to remember where it was. And here I think I'm removing the pulley and the hanging mass. And I'm gonna, you see the hanging mass, it's removed. And I'm gonna start rotation. Oh, by the way, before I start rotation, you will see after I remove everything, the orange indicator is no more on the black. Rotation will actually affect it as well. I'm gonna start rotating until I get the orange indicator to be not above the black ring, not below the black ring. Below the black ring, it means I'm going too fast. Above means I'm going too slow. All right? So here I'm changing the black indicator because I changed the radius, and I'm gonna repeat the experiment. Not to, you see, the orange indicator is no more on the black ring. I'm gonna start my rotation. You see my hand is down because I'm rotating my platform from the rod, and I will start taking measurements whenever the orange indicator you see is on the black ring. Not too fast, not too slow. I need some help. Who can tell me a method to measure the speed, the linear speed of my rotating platform? How many meters per second? How do you do it? I want a method to find the speed, the linear speed, meter per second of my rotating platform. Let's say you are in the lab. What tools do you need to measure the speed? Easy. Speed, meters per second. Can you tell me how many meters does it go in one cycle? I really need your help. I cannot tell you the answer. So the rotating platform is doing a full cycle. Yes, it's 2 pi r, it's the circumference of the circle. So I'm gonna say that whenever it does one full cycle, the distance covered is 2 pi r. Now, to find the velocity, don't you do distance over time? So 2 pi r over time, how do you measure the time for one full cycle? What measuring tool do you need? What measuring tool do you need to measure the time? Come on, people, you are my brightest class. What measuring tool do you need to measure the time? You need anyone? Am I glitching? Am I disconnected? How do you measure the time of something happening? You use a stopwatch, a timer, a clock. Thank you so much. Yes. So you would take your phone and you time. And by the way, all phones or digital stopwatches we have in the lab or on any iPhone, I don't know, Samsung, all of these will give you 2 decimals, all right, in seconds. So we're gonna use, by the way, what if one rotation is too fast to measure? How do you measure the time of only one rotation if it's too fast to measure? What do you do? Frequency is how many per second. So you look for 1 second and you count how many. Yeah, I think it's a good idea. So what we will do is we will time 10 rotations or 5 rotations. Look at the manual. And you will divide by 10 or 5 to find only one period. All right. So here I'm going to say V is distance over time, or 2 pi r over one period. And again, we will not measure one period. We will measure the time to do many periods. Please read in the manual what is. Is it 10 periods or 5 periods? Because I don't want to remember something that is not precise. And to find the period, divide simply by 10 or 5 or whatever number of rotations you do. Now I'm going to take probably some blank space from here to write the equation again. I know that the centripetal force is mv squared over r. You just told me how to find v being 2 pi r, we're talking about the same radius, so 2 pi r divided by the period, right? Now the centripetal force, and by the way, for me to be precise, I'm gonna use capital M because I'm talking about my system. Now the centripetal force is equivalent to the weight of the hanging mass. So it is small m times g. So I wanted to show you this because my other students were confused between which m to use here and which m to use here. all right? So make sure to use under centripetal force the hanging weight, which is small m, and I think it is smaller in magnitude to big M, and big M is your actual system, all right? Here they will ask you to plot radius versus t squared, plot radius versus t squared. By the way, we say y versus x for you to guess what's the y and what's the x. Do it on Excel, easy. They want you to plot radius versus t squared because if you plug in the value for v, you will notice that t squared and r are proportional, knowing that I'm varying the radius for every trial, and definitely the period is gonna change. Everything else is constant. Draw the best fit line done on Excel, measure the slope, just the equation will be enough. The error on the slope, this will take you time. Don't be frustrated. Just think that this is your only chance to practice. Let me help you if needed. Then from the slope, when they say deduce, they want from the slope, which is a lot. It has big M, it has small m, it has g, it has 2 pi or 5 pi squared. What else? 4 pi, not r. And so on to find the centripetal force. So the slope should be related to the centripetal force. And then you need to find the error on the centripetal force by doing the propagation of error. Then you need to compare and then list the sources of errors. To know the sources of errors, watch the video. Probably I said some, or probably you can look at the setup. Think of friction, of limited precision of the measuring tool, anything I'm estimating, and so on. And Mia is asking, how do we do the error in number 4? They want the error on the slope. Let me show you. This is the equation for the error on the slope, okay? So you need to try this one. And I'm gonna show you a video, all right? So I'm gonna open a folder called Data Analysis number 2. In this folder, I'm gonna put a lot of videos, how to do the error on the slope, how to find the slope using a calculator, how to find the slope using Excel, what else? And probably that's it, all right? I wanted to say something. Anyway, you try and let me know. What else? Anyway, I forgot. So Mia was asking, how do we do the error on the slope? Yeah, try to do it. YouTube, Zoom is still recording and we're done anyway, but let me see if we still have anything to add. So yes, I was saying that we vary the radius. You will have different periods. You're gonna plot. You're gonna practice how to find the slope and the error and everything else. All right. So that's it. You wanna try it? Cool. Any questions?
Doctor?
Yes.
So the period is given.
Yes, I'm gonna give you the results. Let me show you how the results would look like. The results should be here, this one. Okay, but I'm gonna probably do some modifications. All right, so I'm gonna give you the mass of the hanging object and I'm gonna call it mass of the system because it was confusing. Mass hanging over the pulley, this is the hanging weight. The radius is gonna vary. The time for 10 oscillations, how do you know it's 10 oscillations or not, or 10 rotations? Read the manual. The manual is still open, I suppose. Is that our manual? Yes. If I go to experiment 3, it says here in the procedure what to do. Maintain, use to time 10 revolutions. I did not want to tell you this. I want you to look for it, but I would want to avoid confusion as well. What else? So to find the period, you do this divided by 10, because we're talking about 10 rotations. Now that you have the period, you will fix the unit. By the way, you want the uncertainty on r and t, and that's it. Don't do on period and t squared because it's not needed. You do t squared, and then you plot radius versus t squared. That's it. The lab report is very short, by the way. It only have those questions, and that's it. Okay, so please focus on the error on the slope. This is the most important part. Now I can see that Mia is asking, how do we find, concerning this issue. I believe this issue is very important. Let me discuss the whole thing. And I believe you will ask me anyway. So we have acceleration to be g sine theta, right? And my question is, I want to find the error on A. So I'm gonna do the derivative of A with respect to g. Probably we did that in the previous slide, previous meeting, squared, but it's okay to repeat, plus derivative of A with respect to theta, error on theta, and all of the squared. And eventually I'm gonna do the square roots, all right? For the derivative, it's not a big deal, we can do it or not. I'm only worried about this guy. This guy is the error, which is 0.5 degrees. Please do not keep it in degrees, change it to radians, because it's not under the umbrella of cosine or sine. Like here, you have sine theta. So theta is under the umbrella of sine. So the answer will not be in degrees. It will be in no unit. It will be unitless. And here you're gonna have g sine theta under the derivative of a with respect to theta. So theta is gonna be under cosine theta, you see? So you have no problem, but the uncertainty on theta is gonna be alone with nothing. So you cannot keep it in degrees. Degrees is not the SI unit. Convert to radians. I suppose you know how to convert degrees to radians. Anyway, if you don't, you can tell me, you can ask me. Do you think, Mia, you're ready to do the error on the acceleration? And don't forget to round to 1 sig fig and to add a unit and to round your value accordingly. By the way, your lab reports are perfect. I think you're gonna do okay in lab number 2. But I think they're perfect only because you ask and dig and analyze and research and think of many other things. That's why they're good. So look at you, you're asking. Let me switch this off. Yes, so look at you, you're asking and things are getting easier for you. So that's it. I'm done, unless you want me to stay for a reason. I'm gonna stop recording now and I'm gonna stay behind for